Okay, so what I want to go through today, this is pretty simple stuff. It's pretty simple jump from the stuff you've been doing. In fact, it's probably easier than the stuff you've been doing. We looked at arithmetic with rational expressions. Now we're going to talk about solving rational equations, right? So a rational equation is just any equation that involves rational expressions. So this is a rational equation because I've got rational expressions on both sides of the equation. So you already know how to do this one. You could have done this one probably, last year, year before that easily. What would you do to solve this? You'd cross multiply. Good. So if we have what's called a proportion, where I just have two fractions equal to each other, that's really simple. All you do there is just cross multiply, right? So we, there's one cross product. We get x minus 18 equals, here's another cross product right there. So we get 2 times the quantity x plus 4, and then I would just solve that for you, right? Okay, good. But there's another part of this. There are some values of the domain that we have to exclude. What are those? 18 and negative 4, because I have some expressions involving x's, algebraic expressions on the bottom of fractions. So we know right away we also have to limit our domain just a little bit. X cannot equal negative 4, and x cannot equal 18, right? So what happens if we get one of those solutions when we solve this? What would happen? What do you think?
Are you recording?
I am recording, thank you. What would happen if when I solve this thing, what happens if I get x equals negative 4? Yeah, I can't keep it, right? That would be an extraneous solution because it's not allowed. So then we would just do the math, right? So x minus 18 equals, if I distribute the 2, I get 2x plus 8. So if I push the x's this way and the numbers the other way, so we're safe. The answer we got is now one of our excluded values, so it works out. Okay? No big. But what do we do if we've got multiple terms? Right? What if it's not just a simple proportion? What if we've got more than 2 terms in our rational equation? Well, here's a really simple, really simple rational equation. This is one that really, you could have done this before you even knew what a rational expression was. In fact, we've done some stuff like this at the beginning of the year. What would we always do when we solve an equation like that? Okay, by what? The least common denominator, right? We'd clear the fractions, wouldn't we? Right? We'd multiply both sides through by the least common multiple of all the denominators, which is the same thing as the least common denominator, right? So what would that be? If we look at all the denominators, we just want to, let's go about this the way we've talked about it over the last couple of days. So the least common denominator, if I break each of these denominators up into their factors, so this one's going to be 3x over, what does 10 factor into? 5 and 2. What does this, well, that one's already factored, isn't it? And then 8 would be 2 and 4, which would factor into, so 2 cubed. Okay? So then our least common denominator has got to be the shortest list of products, or factors, that's going to include all those. What would it be? And you get that because it's equal to, I need to have at least 1 5 and 1 2, at least 1 5, and at least 2 cubed, at least 3 2s, right? So wouldn't that just be then 5 times 2 cubed, cover all my bases, which is just 40, right? Okay, so then I could multiply 40 through both sides. And I don't have to bother with, in this case, this is easier than adding them up, isn't it? I don't have to bother with, getting common denominators and adding fractions. My goal here is just to clear away all the fractions, right? Okay, so when I distribute the 40, and remember this trick, hopefully. Okay, when we distribute, if we've just got constants on the bottom, when I distribute, remember, I know that what's on the bottom is always going to cancel, right? So 40 over 10 is what? 4, right? So we can just cancel out the denominator and multiply 4 times the numerator, which gives us, for that term, we're just going to get 12x. How about when we distribute over here? 40 over 5 is 8. Right? And then 40 over 8 is 5. Simple equation we can solve that, right? Okay, make sense? Okay, so then, what do you think we might do with a problem like that? Okay, same idea, only difference being now we've got some variables at the bottom. Okay? So what do you think? What could I do? Exclude 0. Okay, so first of all, we know that if we're keeping track of all the x values that must be excluded, we know that 0 is one of them, right? We can't have 0. Now what? How can I turn this into a simple equation? I could, so you get a common denominator, is the suggestion. I mean, I could add all this stuff up like I had fractions up, but why don't we maybe try that trick we just did, right? What if we just clear away all the fractions by multiplying both sides through by the least common denominator? What is our least common denominator this time? 8x, good, right? That's the smallest thing that all of the denominators divide into even, right? It's 8x. So if I distribute an 8x through the whole thing, what's going to happen? So if I distribute it here, I end up with negative 8x over 4x. Here I get plus 5 times 8x over 8 equals negative 7 times 8x over 8x. And notice what happens. Everything cancels, right? It has to. If we distribute the least common denominator through both sides, that means the denominators all have to cancel. So here we get the x's go away, and I end up with just a negative 2 on the top, right? Here the 8's cancel, and so I get a 5x. So we end up with a pretty simple equation to do. Negative 2 plus 5x equals negative 7. That's pretty simple, right? So if we add the 2 over here, I get 5x equals negative 5. What's x? Negative 1. How could I check it? Go back. Let's try it. If I put in negative 1, what do I get? So first term, I'm going to get negative 1 over negative 4 plus 5 equals negative 7 over negative 8. So does that work? 1/4 plus 5 equals 7/8. True or false? True. Yeah, it worked. Okay. All right. Let's try another one. So the same. Notice it's the same process we did here, only our LCD is going to have some variables in it too. Okay. So how about that one? take a look at that. It's probably the first thing we want to do here. In this case. It's a little tougher to find the least common denominator this time, right? What might be helpful though, finding the least common denominator? What did you do way back in section, what was that, 5.2 or 6.2? And you wanted to find the least common denominator of some algebraic expressions. What did we do? It's a little harder to do when you think about it. This one was pretty easy because we were able to easily think of multiples of 4x and 8 and 8x, right? That's pretty simple. But it's a little harder to think about multiples of this stuff, isn't it? Right? You want to factor it, right? You want to factor the denominator. So this first term, I get -5 over, how's the bottom factor? Okay. Plus 1/3 equals, how about this guy? Okay, so now I can pretty easily make my list, my least common multiple of all those denominators. All right, so what's that going to amount to? Okay, good. I'm going to have a 3, right? That's the only constant that shows up in those. So I know I have to have at least one 3. I have to have at least one x plus 5. And I have to have at least one x minus 3. Right? Now, let's not multiply that out yet, though, right? Because we want to be able to cancel these factors. But that's what I'm going to distribute through both sides, right? So if we do that, so what's going to happen then? If I distribute it to this factor right here, what's going to cancel? The 3 and the x plus 5. All that stuff cancels, and I'm left with just an x minus 3 times my numerator, right? Okay, how about this one? What's going to cancel here? 3 is going to cancel, so I'm just going to get 1 times x plus 5 times x minus 3, right? And then what's going to cancel over here? Okay, so 3x minus 3 cancels, so I just get x plus 5. Okay? All right, but I guess before we go on, we should probably, we've got this factor. Any values of x we need to exclude based on these factors in the denominator. Okay, so we can't have, we can see, everybody see that? So right here we know that because of this factor, we know x cannot equal -5. And because of that factor, x cannot equal 3. So those, we put those in our list. Right, have to exclude those. And now, after cancellation, this is going to be an easy equation, isn't it? Right? If we just clean this up a little bit, if I distribute the -5, I get -5x plus 15. What are we going to get here if we expand that out? So I'm going to get an x squared minus 3x plus 5x would be a plus 2x, and then good, minus 15 equals x plus 5. What do we need to do with this? Okay, we've got to put it in standard form, right? Put it all on the left side so we get a positive number of x squareds. See, we get some good cancellation, though, don't we? The 15s cancel. We end up with x squared minus 5x plus 2x is minus 3x. I'll subtract another one, so we get a minus 4x, and then just a minus 5. Okay? And then, right, so now we've got a quadratic equation in standard form. So we can solve this in the best, easiest way, which in this case would just be factoring, wouldn't it? So we can factor this into what? So we get the solutions, x equals 5 or x equals -1. Now, are those in my list? No, they're not. -5 is, but 5 isn't, so we're good. Those would be my solutions. Okay, getting the idea? Maybe let's just go through one a little bit harder one, and then I think you can just work on this. Let's try that one. We can do that one, we can do it here. But these aren't, I mean, isn't this almost easier in a way than adding up the fractions? To me it is. Right, because you don't have to deal with adding up common denominators. You can just clear everything out and then just solve a regular quadratic equation in this case, right? Okay, so what do we get from our first term here? By factor the bottom. Okay, magic numbers are x plus 6, x plus 5. So right away we can eliminate -6 and -5, right? Minus, how about this one? X plus 5, so we already got the -5 eliminated. And then -6 over x plus 6, so we already have our -6 excluded. All right, so what's our LCD going to be this time? Okay, good. I need, for the constants, there's only one constant. I need at least 1, 2. So we got that. You're going to need at least one x plus 6 and x plus 5. And that covers all our bases, right? So if we distribute that through everything then, okay, so first term, what cancels? So good, so those guys go away. All I get is the 2 on top, so I'm getting just a 16. Okay, now subtracting this one, what's going to cancel there? Okay, so the 2 cancels, the x plus 5 cancels, leaving me with just an x plus 6. Multiplied by the x plus 15 that's already there, right? And then over here, looks like just the x plus 6 is canceled, and so I get a -6 times a 2 times an x plus 5. And you can probably take it from there, right? Now it's just going to end up being a quadratic equation in standard form that we just solved. Okay? Make sense? Okay, that's it. I think there's only like 5 or 6 problems in that assignment. Okay, you're good. You can work. If you want to test, you can.